Model-based methods. For the inspection of PWS with model-based methods, the analytical model, introduced in Section 2 can be used. The idea is to adapt the model to the experimental data via fitting of the parameters. The fitted parameter vector is used to separate the healthy state. Using principal component analysis, PCA, they can be aggregated to a damage indexed model. For details, the reader is referred to. An advantage of this method is the non-necessity to include temperature information for the test and application, also if the influence of environmental conditions should be compensated. Nevertheless, during training, temperature information is necessary. As already shown in EX 7-17, the model itself includes a bunch of parameters. Although most of them cannot be changed due to damage, for example, nominal radius of the PWS, these parameters will have some variations resulting from different batches, different bonding procedures, and so on. Therefore, the model needs to be adapted to the experimental baseline first. With this updated model, the model-based transducer inspection procedure can start. The major disadvantage of this procedure is the high correlation of the different parameters on the influence on the susceptance spectrum. The adaptation of the parameters is based on optimization procedures, which do not necessarily result in physically meaningful parameters. Moreover, the user needs to know a multitude of parameters about the applied PWS before being able to use this method. Data-based methods. The avail of the EMI spectrum started from using the susceptance slope coefficient SC as the damage indicator. As the capacitance is a linear factor for the susceptance, it can be seen as an advanced alternative to solely measure the PWS capacitance. It is measured in a frequency range up to a small share of the eigenfrequency, which interrupts the constant slope. Although it has been shown that not all faults can be detected with this method, it is a simple method, which can be applied easily, and which detects severe damages like fracture of the PWS. The employment of more information from the susceptance spectrum than only using the slope is also possible with data-based methods. 12 parameters, which can be extracted from the susceptance spectrum, have been listed. After extraction from the spectrum, they are used for PCA. The first principal component, PC, can be taken as damage indicator for degradation and breakage. While data-based models in general are less numerically expensive than model-based methods, one difficulty of this method is to extract the parameters, depending on the data quality. The inclusion of more information of the spectrum is also possible by using the correlation coefficient and subtracting its absolute value from 1 to achieve a damage index. This way, no additional extraction of features is necessary. VKL being the entries within the covariance matrix V. The correlation coefficient CC is 1 for two susceptance spectra, which only differ by a proportional change this way. The slope is an insensitive parameter for this method. Nevertheless, PWS faults change the characteristic shape of the spectrum at resonance also for small faults. This is focused, when using the damage index based on the correlation coefficient DIC.